So in this video I'm going to walk you through the math behind the different types of constructions of fasteners. These problems I'm going to use to demonstrate are in the back of chapter 15. The SP problems 6, 7, and 8 are what I'm going to cover. So I'm going to hop over to a Excel file, and so I also have listed up here the different pages I'm going to use to reference. So I have what they call, second here. So SP156, I have a hex bolt. So they provide me the major diameter of the hex bolt, and now I need to know the widths across the flats. So if I go to page, well, I don't need that yet. So I'm going to go to the back of the book, Appendix B. On page B4, they provide some different equations for different types, different sizes of hex bolts. So the equation for widths across flats, I look at the chart on B4, and there's a column for widths across flats basics, and I have a size of 3/4. So I find the range with 3/4, and the equation for that is just going to be 1.5 times D, which is the diameter of the bolt. I did not press equal, so that did not work. 1.5 times my bolt. And then, so that's correct. Now the width across the corners, so the width across the corners, the equation for that is on the last column of that chart, and that's going to be a 1.1547 times F, which F was the width across the flats. Click on that, and that was right. And then one more time, I need the height of the head. So that's the first column there. So I'm going to press equals. That's H equals 0.625. Come on. Times our diameter plus 0.031. And press enter. And I got that right. And now for the normal clearance hole, I'm going to jump back to page 1516, and there's a table 15.91 that has some equations on solving that. I have, once again, a diameter of 3/4, so I'm in between 1/2 and 7/8. So that is our diameter plus 1/16, 0.065. And I got that one right. Alright, so now I'm moving on to 7, and that one is a hex head bolt, or hex head screw cap screw. That is also back in Appendix B to solve for that. That is going to be on page B6. So my max head diameter is in that first table under B33. Max head equals H equals D. Wait, nope, that's head height. Sorry. Head diameter is 1.5 times D. So 1.5 times D. And as I just said, my hex head height is just equals D. Normal clearance hole, once again, go back to page 1516. I have a size of 7/8, which is the same equation from before, so that's equal to D plus 0.0625. And then on our counter bore diameter that needs to be drilled to fit the nut into is on page 1517, and under figure 15.92 you can kind of see how things are labeled, and then the equations are in the paragraph above that. So a counterbore diameter is equal to, that's a C1 in the diagram there, so C1 equals D1 plus 1/8. So our D1 is our head diameter plus 0.125. And then the depth is the CH, which CH equals our head height plus 1/16. There, plus 0.0625. And then the last one is a countersink. So I'm going to jump back to the appendix B again, and then jump over to page B9 because I have a slotted flat countersunk. So my head diameter is equal to, I have an inch major diameter. So my equation is equal to 2 times 1, the diameter, minus 0.125. And that's right. And then the head height is 0.596 times our diameter minus 0.075. And that came out way wrong because I forgot a decimal place. There we go. So for our normal clearance hole, we jump back to page 1516, look at the chart. We see that for a 1-inch diameter, we need to take our diameter plus 3/32, which I can just type in like this, and there we go. Our countersunk diameter, we go to page 1517, and that's going to be D1 plus 1/8. Our D1 is the head diameter plus 0.125. And then countersink angle, if you jump back to page B9 in appendix B, that's going to be between 82 and 80 degrees. I'm going to leave that last bit off of the assignments because that's what it always is. There will be a couple assignments posted on Canvas dealing with these kind of problems. And if you need a little more help or to dive in this a little deeper, if you download that website that comes along with the text, the section on threads and fasteners is pretty helpful. It's got a lot of interactive activities and exercises built into it. So that's going to be, when you open up the website, that's underneath the engineering graphics content and threads and fasteners.